Welcome to the boardroom, everyone. I'm acting as your managing director today, and this explainer is an exclusive executive pitch masterclass. We are looking at a very specific client brief today, Cambridge Mathematics Syllabus 9709, specifically topic 1.8 on definite integrals. We're going to treat this exactly like a high-stakes corporate proposal. I'm going to teach you how to structure your exam responses with the absolute clarity, precision, and authority of an elite executive consultant. We're taking direct insights from the examiners themselves to build out your strategic playbook. So grab your notepads, settle in, and let's get right to work on mastering this brief. So let's address the elephant in the room. Why do so many incredibly capable candidates just bleed easy marks on definite integrals? It's a tragedy we see all the time in the principal examiner reports. To illustrate this, let me introduce you to two junior consultants I was working with yesterday, Consultant Alex and Consultant Sam. Now, Alex has amazing data points, knows every integration formula perfectly, but delivers a terrible executive summary. The presentation is totally unreadable. On the other hand, we have Consultant Sam. Sam is a highly persuasive speaker, great at writing out final conclusions, but completely lacks the physical asset backing, meaning Sam skips the core calculus working. Both of them failed the pitch. Why? Because they understood the underlying math, but completely failed the execution on paper. Today, we are going to use direct examiner insights to fix both of their approaches, and yours, right now. Here is our strategic roadmap for today's briefing. 1. Core principles. 2. The procedural framework. 3. Examiner warnings. And 4. Critical analysis. Let's move. Section 1. Core principles. Let's head into the strategy room and establish our foundational mindset. Here is the clear dividing line between average candidates and our top-performing consultants. We had a massive structural strategy debate yesterday. Junior consultant Alex argued for superficial breadth, just memorizing a massive wide array of standard formulas to get by. But consultant Sam correctly pointed out that the Cambridge syllabus explicitly states that memorization simply won't cut it. You need analytical depth. What does that actually mean for your portfolio? It means developing a deeply connected conceptual understanding of integration. The board, or in your case, the examiners, will intentionally tweak the scenario specifically to test if your core understanding holds strong in totally unfamiliar, volatile contexts. If they change the underlying variables, your executive understanding of the integral absolutely must hold strong. You can't just rely on a formula sheet. You need to understand the architecture of the math. To achieve that required analytical depth, your proposal has to satisfy 3 strict compliance standards, which Cambridge calls assessment objectives. Let's break down the domains. First, AO1, knowledge and understanding. This is knowing the fundamental rules of integration. Second, AO2, application. This is where you actually set up the definite integral with the correct limits based on the specific client prompt. And third, AO3, analysis. This is the big one, folks. Academic benchmarks for this topic strictly require logical, structured reasoning. Every single step of your mathematical argument must logically and clearly justify the next one. It's exactly like a boardroom pitch. You can't just skip to the end and expect us to trust your numbers. You have to prove the journey. Section 2, the procedural framework. Let's explore the method mark strategy. Okay, before we fix Alex and Sam's pitch, I need to pause the slide deck for a quick administrative update. To ensure your academic portfolio remains highly competitive, subscribe to our channel Ace the Exams at the handle @AceTheExams and enable notifications for our weekly consulting insights. All right, let's resume. Yesterday, Alex and Sam encountered a critical flaw in their mock proposal. Their syntax was a mess. So I stepped in to teach them how to align their math with a standardized sequence, essentially adopting the Peel paragraph matrix: point, evidence, evaluation, link for calculus. Step 1, identify your key elements. What are your limits? What is the function? Step 2, apply the relevant principles. Step 3, execute your analysis with crystal clear working. Listen to me carefully. This right here is where the method marks live. In consulting, we call this the billing phase. If you don't show the work, you don't get paid the marks. Step 4, verify your results. And step 5, present in format. If you just punch numbers into a calculator and spit out an answer, you are literally leaving guaranteed method marks sitting on the table. And speaking of that final step, presentation, the syllabus explicitly notes that practical application in mathematics develops professional skills. This isn't just about getting the right number. It's about how you package it. You need proper headings, correct terminology, appropriate formats, and clear annotations. Think about it. If you slide a messy, coffee-stained napkin across the boardroom table to a CEO, they're going to throw it out, right? Well, if your exam working is structurally unreadable, the examiner isn't going to award you full marks, no matter how genius your mental math is. Your syntax and formatting matrix must be flawless. Show the work clearly, cleanly, and professionally. Section 3, Top 3 Examiner Warnings. It's time for our live risk assessment. We're moving into the live audit workshop for all of you watching. I want you to imagine a 60-second visual timer right now. You are auditing a past paper. Case 1, mistake number 3, ignoring the context. Imagine extracting insights under pressure. You might have executed a beautiful, flawless integration, truly top-tier calculus, but if the client brief asked for a physical area in specific real-world units, and you just dropped a raw, unitless number on the final page, well, you've completely failed the application domain. You missed the big picture. Always, always anchor your final answer back to the actual real-world brief provided in the question. Let's look at Case 2 for our risk assessment. Mistake number 2, rushing the finish line. We see this constantly. Under the extreme pressure of the exam clock, candidates completely forget to check their final format and visual presentation. They start panicking and they'll scribble their final limits and calculations in a way that is just entirely unreadable. Where exactly does this answer lose structural credibility? Right at the very end. Once again, if the examiner cannot clearly read your final annotations, they cannot legally award you the marks. Pace your pitch. Do not sprint through the final slide of your presentation. And here it is, the ultimate #1 critical failure revealed by the examiner reports. Students forgetting to include proper mathematical format entirely when setting up their definite integrals. Let me be very clear. If you omit the integral sign, if you drop the dx, or if you fail to clearly state your upper and lower limits during the substitution phase, you completely break the standardized sequence. And just like that, poof, your method marks vanish. Dropping the dx is like sending an email without the attachment. It renders the whole operation invalid. Do not make this rookie mistake. I want to pause here and let this direct examiner alert sink in. Candidates consistently confuse key terminology. In the corporate world, confusing your terminology during a major pitch essentially tells the board that you lack foundational knowledge. It destroys your credibility. When you are writing extended responses or tackling high-tariff, multi-part questions, mislabeling your terms tells the examiner you lack that core conceptual understanding we discussed at the start of this masterclass. The worst part? It is a completely avoidable error. So what's the fix? Here is your actionable, immediate terminology protocol. Always, always define your terms before using them in extended responses. You have to establish absolute clarity first. Before you execute a single line of complex math, define your variables. State exactly what your integral actually represents in the context of the problem. Doing this perfectly aligns your syntax with the examiner's expectations and sets up a bulletproof argument. Section 4, Critical Analysis and Evaluation. Welcome to the advanced tier. To close the deal, you need high-tier evaluation skills. Evaluating evidence quality means looking much deeper than the surface numbers. Top-scoring consultants actively identify limitations in a mathematical model. They rigorously question the assumptions made in the initial prompt. They provide alternative interpretations, and crucially, they clearly explain the downstream effects of these factors on their final conclusions. If you are asked to compare two different mathematical approaches, you must identify both the similarities and the differences, support every single point with concrete evidence from your working, and draw highly justified conclusions. This is how consultant Alex and consultant Sam finally succeeded, by combining Alex's raw data precision with Sam's high-level evaluative analysis to create a polished final draft. And that leads us to your ultimate problem-solving sequence for complex definite integrals. It's a 3-step cycle. Deconstruct, solve, and evaluate. And listen up, that final step, evaluate, is totally non-negotiable. Always check your final answer for reasonableness. Let's do a quick business viability check. If you are calculating a physical area using a definite integral and your result yields a negative number, you must immediately recognize that limitation. A physical area cannot be negative. You either need to fix your working or intelligently justify your recommendation by explaining the position relative to the x-axis. Checking for reasonableness is what separates the juniors from the executives. As we wrap up this boardroom session, I want to deliver your executive framework summary checklist. Here's a quick, actionable memory hack directly inspired by the syllabus notes. To ensure you lock in this exact procedural framework, identify, apply, execute, verify, present. Create a mnemonic using the first letters of those key terms. IAEVP, whatever phrase works for your brain. Write that mnemonic at the very top of your scratch paper the literal second you sit down for the exam. It will serve as your personal compliance checklist, ensuring you never drop a structural mark again.
So, as we close this pitch, I leave you with a provocative question. How will you adapt your revision strategy today to integrate these exact examiner insights? Because knowing the math is only half the battle. Presenting it with clear, logical, executive authority is what actually secures the top-tier grade. To ensure you keep leveling up, I need you to subscribe to Ace the Exams at the handle @AceTheExams, enable the notification bells so you never miss a masterclass, and comment down below with your current academic level and your target subject. Now, get out there, practice these frameworks on past papers, and go close the deal.